Okay, here we go. 1.3 Markerboard practice. I'm stepping on my cord. Okay, 1.3 Markerboard practice tutorial. First thing we're going to talk about domain and range. And so in class I said put your hands in a prayer-like position, start at the origin and spread out. And you can see when we do that, that our domain is starting with -2 and ending with 3. If we go beyond -2 and beyond 3, there's nothing. There's no graph there. So our domain starts at -2. We're going to use a bracket because -2 has a filled-in dot. And it stops at 3. We're also going to use a bracket because 3 is filled in. Then for range, we're going to put our hands in the opposite direction and go up and down. And so the highest up I can go is 1. If I go past 1, there's nothing. There's no graph up there. The lowest I can go is -1. If I go below -1, there's nothing there. So our range goes from, we're going to put our smallest first, even though, yes, we just talked about 1. We're going to do our smallest first at -1, which is also a bracket, and at +1, which is also a bracket. Okay, looking at this one, once again, domain, hands like a prayer. I told you to remember domain, main religion. You put, I know it's really stretching it. But that's hopefully how you can remember. You open up your hands. The farthest out you can go with your left hand is -3. You can't go beyond it. So we know our domain starts at -3. We use a bracket because these circles filled in. And the farthest your right hand can open up is a +3. If you go beyond that 3, there's nothing. When you look up and down, if you go past 3, there's no graph there. So the domain ends at 3 with a bracket. Then if you do the opposite with your hands parallel to the x-axis and open them up, the highest you can go looks like 2. Can't go any higher. If you go higher and you look to the left or right, you don't see a graph. And the lowest you can go, it looks like, looks like -1.2. We're just going to stop at -1, and we're just going to say our range is from -1 all the way up to 2. It doesn't go any lower technically, and it doesn't go any higher. For this one, if we open up our hands, this one might be a little confusing because it kind of, when you look at a quadratic and you look at what it's doing, it almost looks like it's heading straight down, but we can tell that there's a slight curve to it, and that eventually, even though it looks like it's going more straight down than curving, it does end up, if we put our hands way, way out, like way, way out, somewhere over here, -100, or somewhere over here at +100, all right, not quite -100, +100, there will be a graph to look at when we look down. So our domain, looking at this graph, is going to be all the way from -infinity to +infinity, though we cannot open our hands that wide. I guess we could and just point our fingers, like, infinity on both sides. All right. This makes sense because if we look at a quadratic algebraically, we know that there are no limits placed on x, or no difficulties where we say x can't be something. So the domain is from -infinity to +infinity. When we do the range, the highest up we go with the range is at a 4. And the lowest we go, well, we're at -4, but those arrows mean they continue to go all the way down. And so our lowest is going to be -infinity, and our highest is going to be 4. And we're going to close the brackets because it includes 4. There's actually a value, there's an x value and a y value there. Okay, another quadratic. Once again, if you open up your hands, we're going to be going for the domain from -infinity to +infinity. And for the range, the highest it goes is 0, and the lowest, of course, -infinity. Okay, so we're going to determine the intervals on which each function is increasing, decreasing, or constant. Let's get the constant one out of the way. Over here, I'm looking at when x is -3. Something's going on, and as I'm looking this way, I notice that all the way from negative infinity until it comes to a screeching halt at -3, that's just a constant. It is the line y equals -2. So as I'm reading it, even though I wrote my arrow that way, as I'm reading this graph coming down the x-axis trolley, and I'm looking at what's going on, as I'm looking out my window, I see that it's just a constant flat line of y equals -2. Screeches and halts at -3. So at -3, all of a sudden, when we look up from our window, I know you guys probably don't like that, but it's just, thinking about traveling on this x-axis on a trolley and just looking around, just seeing what's going on. That's how we can describe our graph. So when we look up, we see that at -3 starts our decreasing. Is it decreasing at -3? No, it's not. It's just our starting point for the decreasing. Then as we go down, we're decreasing all the way till we come to a screeching halt at 0. So as we're moving along the trolley, right at 0, we're going to stop. We will have an open circle because the decreasing has ended. Bam. Not an open circle, but a bracket. And then as we're still traveling, and as we're traveling on our trolley, we notice, okay, at 0, I'm starting something new. I'm starting my increasing. And so I'm not using brackets because at 0, we start the increase. And then, as we're moving this way, we notice it increases, 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 and it increases without bound. So we're going to say it increases that way. Those are the intervals over which this is definitely a piecewise function, is increasing, decreasing, and is constant. Okay, with this one, even though our arrow, of course, is going this way, we are moving this way. We're reading this graph from the left to the right. So as we're looking up, as we're moving along the x-axis, we can see that we've got a constant flat line, a constant line of y equals 1 going on until we come to a screeching halt at 1. So we know from negative infinity all the way until 1, it is constant. We're going to include 1 because a constant's a constant. So then as we keep moving along the x-axis, we notice that we start a new trend starting with 1, and it is increasing. So we're going to start it at 1. It's our starting point. And as we move along the x-axis, we notice that it keeps increasing until we stop at 3. Then we notice at 3, it starts a new pattern of decreasing. So we go to the decreasing, and we started at 3. And as we move along, it's decreasing, decreasing, decreasing. It's decreasing until right at 6, it stops. And then it starts to become, as we're moving this way, another constant again, all the way up to infinity. So we have a second interval of constant. Let's see, we're going to put 6 and infinity. So I'm hoping that you're not getting frustrated with this, because it's something to just look at a graph and just go, okay, there's my graph. And there's something about analyzing the graph and saying, okay, what's my domain? What's my range? Where is it increasing? Where is it decreasing? When you can start analyzing stuff like that, that's a deeper level of understanding. And so I'm hoping that you're seeing the value behind it, especially for those of you that are going to go on to calculus. And for those of you that aren't, well, it's on your test. So it's another reason why you should know it. Okay, here's a piecewise. And basically it tells me for all the numbers that are less than or equal to 1, we follow this rule right here. So what we're going to do is we can make, like we did in class, a little XY table, and we can say, well, x can equal 1, so I'm going to make x be 1. I'll plug 1 in. 3 times 1 is 3. I have a point. All right, what's the next number? X is less than 1. What's the next integer? 0. I can plug 0 in. So 3 times 0 is 0. And let's just do one more. If I plug in the next integer that's less than 0, I'll have -1. And we'll plug that in. And so we'll have 3 times -1 is -3. I'll come over here and I'll graph. I have 1, 3. I'm going to put a closed circle because it says x is less than or equal to. So when I see that line, I can make the closed circle. And I'll go ahead and put the rest of my dots. And you could also graph it like we talked about in class, just looking at it as, oh, I've got a shadow. That's a really bad line. I can do a little bit better than that. Okay. So this part that I just graphed took care of this part of the piecewise function. Now we're done with that. Now we're looking for, well, what happens when x is greater than 0? What's going to happen? I don't have any values for any of these x values. So now I've got to look at the second part of the piecewise function to see what to do. So when I look at this, it says if x is greater than 1. Now, you're really, really tempted to go, oh, x greater than 1, let's see, the next integer that's greater than 1 is 2, and start there. And if you do that, you will be part of a group that will get that wrong, and you don't want to do that on the test, so you want to start practicing the right way, right? It's not that practice makes perfect. I think it's perfect practice makes perfect. I didn't make that up, by the way. Someone else did. All right, so like we talked about in class, 1 is going to be the placeholder. This 1 is very important. We're still going to plug it in. So 5 minus 1, if x is 1, 5 minus 1 is 4. I'm going to go over there right now so that you don't be like this, oh, look at this. Okay, 1, 4. I'm going to go over 1. I'm going to go up 4. And I'm going to put an open circle. That's my placeholder. I need that. So now I can go ahead and say, okay, the next integer greater than 1. Well, it's 2. I'll plug that in. 5 minus 2 is 3. And I'll get one more. The next integer is 3. 5 minus 3 is 2. So I'll come over and plug in or plot 2, 3, and 3, 2. And there's a nice line with a slope of -1. Now, why by the way, this is the answer, but I'm going to talk about why did we have to do this. If we didn't do this and we didn't get this point, we also wouldn't have gotten that stuff from here to here. If we would have just started here at 2, 3, this is what our graph would look like. It would have started here and just included this stuff. You would have gotten it wrong. Because these values right here, there's like a million, trillion, billion, quadruple trillion values in there between when x is 1 and x is 2. All right, that's a crazy thing, isn't it? Really, there are an infinite amount of values between when x is 1 and x is 2. That always just blows my mind when I think about it. All right, so please remember to, even though it says x does not equal 1, we're still going to plug 1 in for x to find out where our placeholder should be. Okay, now this is our greatest integer function. We call it a step function. And so basically it's saying, all right, what is the, let's push the words aside and put the 3 on there. What is the integer that is less than or equal to what's in here? A 3. Well, it's just a 3. Okay, that wasn't as fun as when our number is like 0.97. So we're going to go ahead and use the beautiful number line and put the 0.97 and say, okay, what integers is it between? Well, 0.97 is almost at 1. It's between 0 and 1. And it's really kind of sad that it's so close to 1, but yet the greatest integer function says if it's not exactly 1, it has to fall back to 0. And so when you see the double brackets with the 0.97, you know actually that's equal to 0. And then when we have 5.7, same thing. Do you have to do a number line? No. I just really want you guys to understand the whys. Looking at it, we fall back to the left. It's almost at 6, but it's not at 6. Too bad. So sad. It falls back to 5. Some of you said rounding down, and rounding down could work, except for when we get to negatives, you got to be careful. So negative 4.1 is about what? Right here. So rounding down, when I think about rounding down, we think about that being -4. But really, when I look at it, it's not quite to -4, so it's got to go back to -5. So be careful if you don't use a number line when we have negatives. Let's see if we have any more left. Yep, -1.9. So we'll go -1.9 right here, and it falls back to -2, and in a weird way, that doesn't feel like it falls back. But look at the number line. So please promise me you'll do a number line when you see these negative numbers. I think it's essential. All right, -0.1, that puts us right here. It's so close to 0. Nope, it's got to fall back to the left, which is -1. Okay, even or odd. We did these in class, and we basically discovered that as long as we had x raised to an even power, it was going to be even. I'm not going to plug in 2 and do 2 to the 8th power because I don't have a calculator with me. But you can pause, and certainly, basically, we would find out that f of 2 would equal f of -2. Both plugging a 2 into this or -2 is going to give us the same answer. So basically, f of x would equal f of -x, and that's another way to think of even functions. Okay, y equals x. We could plug in 2, so if we had f of x equals x, which is another way to put this, and we plugged in 2, we get 2. If we plugged in -2, we'd get -2. So that is odd because it's not odd, but you know what I mean, it's an odd function. And it's an odd function because the answers are opposite of each other. So you put in opposite x's, you get out opposite y's, and that makes it an odd function. When we look at -4x, let's try. We're going to change it to f of x equals -4x. Let's plug in our 2. So that's -4 times 2, which is -8. And if we plug in our -2, it's -4 times -2, which is +8. So once again, this is odd. We plug in x's that are opposite each other, opposite in sign, and we get opposite y answers. So wait, did I say that was, yes, that's odd. I hope I didn't say even, but it is 6:30 and I'm just about ready for open house, so who knows, it's been a long day. All right, I really hope this has helped you, and good luck with your homework. See you in class.